Hi everyone. So we continue on the lesson topic 1. This is video number 2. So composite functions. This video won't be so long, but I just wanted to have a separate video because that's important, and so I wanted to just have your attention to just one specific lesson in this video. Composite functions. So I talked about addition of functions, subtraction of functions, multiple functions. So, and we did questions of those. So another operation we can have on functions is composite function. When you substitute, instead of x that you substitute a number, you substitute another function. Okay, so I have to start with an example here. See, you have g of x, x plus 1. So whatever you give, it adds 1 unit and gives you back the result. Okay, so I want you to find g2. Okay, so you will say, okay, g2, so you said whatever you give, it's just plus 1, so it's 2 plus 1, which is 3. Okay, but now I say, okay, what is zs squared? Okay, but see, we don't pay attention here. Zs squared is another function. Okay, so it doesn't matter. I just substitute the same thing here. I just substitute the same thing I see for x. Okay, so g of zs squared is zs squared plus 1. Okay, maybe I can make you just to smile. Just I say, okay, sometimes I say so in my class. So for example, if I say g Nilu, okay, so that's Nilu plus 1, which is my name. Okay, so whatever you substitute for x, you can just substitute it for x. Try to use BEDMAS and simplify, and if you need to do powers, and so to simplify it and then find the answer. Okay, so before I continue, maybe I can talk about the notational, for example, composite functions. How do we do that? Okay, see, if I have f of x, okay, and I have g of x, so I have, for example, I give x and it gives me the result. So based on what I have in x, I give I give gx, and then it gives me back the result based on what I have in g. But then I say, okay, what is f of gx? Okay, see, I substitute what I see in gx, everything, I substitute this for x in f. So I substitute this in x for f and I find the result. I also show it with FOG. Okay, so FOGX. So FOGX is f of gx. Okay, so how about GOF? Okay, GOFX. So this wasn't part of the note, but I mean the notation GOF. But I was thinking maybe you see it somewhere, so you need to know this is G of fx. G of fx, which means you substitute the whole fx in so for x in g. Okay, so let's do example. Okay, so look at this. I have gx equal x plus 1. I have fx equal x cubed. Okay, what is g of fx? Okay, so g of fx, I try to do it step by step and then I don't make mistake. Okay, so g of fx. Okay, so what is fx? Fx is x cubed. So what is gx cube? Okay, okay, so instead of x in g, so I put x cube to x, I substitute instead of x in g. Okay, okay, so this is x cube plus 1. Okay, how about if I say, okay, what is f of gx? Okay, means f of, I do a step by step, x plus 1. Oh, okay, so I put x plus 1. I don't separate it. No, I don't do x and 1 separate. X plus 1 is one item. I put x plus 1 instead of x in f. So it is x plus 1 power 3. which I can simplify and, for example, use Pascal and just expand it. Okay, but if I don't expand, No. Okay, so this is, but I want to show you this is not the same as this. No, 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 it's not the same as this. So f of gx and g of fx are not equal. Maybe just exceptional cases, but not necessarily. Okay, practice. So you have h of x, and this is not, and you want to find h of x minus 1. It is not hx minus h1. No, 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 no. Don't separate. X minus 1 is one item. Oh, okay. So it is hx minus 1. It's 6x minus 1 squared minus 2x minus 1. I just need to simplify. This is x squared minus 2x plus 1 minus 2x plus 2. Okay, which is 6x squared minus 12x plus 6 minus 2x plus 2, which is 6x squared minus 14x plus 8. Okay, so that's the answer, right? So how about this one here? How about this one here? Okay, so I better zoom. Okay, so f of 5. So oops, sometimes it doesn't help me. Okay, yeah, what is f of 5? So find f of 5. So f of 5 is 5 squared minus 3 times 5 times 5 plus 4, which is 25 minus 15. Okay, 10 plus 4 is 14. F of 2. F of 2. Can I bring 3 inside? No, 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 I can't. Okay, 3 stays out. So it is like, this one is like, so for example, is like x, for example, minus 3y, for example. Okay, because I don't want you to mix this with here, so I just remove it. But I just want to show you. Okay, so f of 2 is 2 squared minus 3 times 2 plus 4, which is 4 minus 6 is minus 2 plus 4 is 2. And how about f of 3? So it's 3 squared minus 3 times 3 plus 4, which is 9 minus 9, and that's 4. So what is the result here? The result here is 14 minus, so I just maybe change the color. So it's 14 minus 3 times 2 divided by 2 times 4. Okay, which is 14 minus 6, that's 8 divided by 8, that's the result equal 1. Okay, so the last but not least page, okay, so is here, and so I want you to calculate this, and you are going to see this in future. Okay, so you are going to see this in future when we want to talk about derivative. Later we use this in derivative, but right now I'm not going to talk about the derivative part, because I need to talk about limit, and then I use limit to do so for this thing I have to do the derivative. Okay, so I don't talk about that, but I just want to have your attention that later we use this in derivative. Okay, so let's calculate this. Okay, what is this? Okay, look at this. X plus d is for x, so you substitute x plus d instead of x. Okay, so it is x plus d squared minus x squared divided by d, which is x squared plus 2xd plus d squared minus x squared over d. Okay, can I cancel this and this? Yes. Then it is d times 2x plus d divided by d, and I cancel d and d. I have 2x plus d. Okay, so later I am going to use this to calculate derivative of function x squared. Okay, but not now. Not now. Okay, so let me just to check something here. Okay, so maybe I can do, for example, I can do another example here, which, for example, I can talk about domain, for example. Okay, so just as an example. Okay, so if I have fx equal radical x, okay, you know domain is just from 0 to infinity, because I cannot use negative. I told you domain is what you can use for x, okay, and range is when you use the domain, what is the result? Range is the result. I'm not going to talk about range here, but this is the domain, positive. Okay, maybe I say gx is x plus 8, and the domain of that is just r. Okay, so I can use all the values. Okay, so I want you to find f of gx, which is f of gx. Oops. Okay, which is radical gx. Oops, so now I do a step by step. So it is f of x plus 8, and which is radical x plus 8. Okay, so what is the domain here for f of gx? Okay, the domain here, I cannot say I start from 0 and go up. No, because x plus 8 must be positive. Okay, and 0 can be 0. Okay, so x is more than minus 8. Okay, so the domain here is from minus 8, oops, from minus 8 to infinity. Okay, how about GOF? Okay, so if I do GOFX, which is g of fx, what is fx? Which is g of radical x, which is radical x plus 8. Now what is the domain here? The domain is the same, so from 0 to infinity, because you just see x on the radical. Okay, so I just want to have your attention when you have so for example f of x and g of x, then f of gx and g of fx, they don't have exactly the same domain that you had before. Okay, no. Okay, so we are done with topic number 1. So I finish here, and for topic number 2 I start with another video. Thank you so much. Bye.